Alright, so today we're going to finish up our little three-part series on going from percent composition to molecular formula, which is the ultimate goal of this process, to use the percent makeup of a compound to find the actual formula of the molecule. So we'll go ahead and jump right in. We'll list out the steps for finding the molecular formula. So the first step is find empirical formula. So we know that the molecular formula is always some multiple of the empirical formula. So if the empirical formula were, we'll just say x2y, for example, the molecular formula could be x2y, it could be x4y2, it could be x8y4, so it has to be some multiple there. So the second step is to find the mass of the empirical formula. Okay, so then the last step, multiply the empirical formula by the molar mass, okay, divided by the mass of the empirical formula. Okay, so you'll see here I use the molar mass of the molecular formula. So in order to find the molecular formula, we have to have found the molar mass of the molecular compound already. So oftentimes that'll be given to us because we can find that through mass spectroscopy, which we might discuss at the end of the year if we have time. Okay, so let's go ahead and look at a few of these examples and kind of learn the steps by doing here. So in the first example, the empirical formula is found already for you. So we could have gone through the steps based on the percent compositions and found it ourselves, but here it was already found for us. Okay, so we can go ahead and jump straight into step number 2. Okay, so step number 2 is finding mass of the empirical formula. So I add 12.01 plus 1.01. So I see that the mass of this is equal to 13.02. So the third step is multiply the empirical formula by, empirical formula by the molar mass divided by the mass of the empirical formula. That's a lot of words. So we want to see how many of these, how many CH's it takes to make the actual formula. So let's do 78.110 grams divided by 13.02 grams. So we have 78.11 divided by 13.02. So if this number, so I got in the calculator 5.9992. So if this number doesn't come out to a whole number, or something that can very logically be rounded to a whole number, you've done something wrong here. So now we simply multiply the empirical formula by this number. So we don't do this. Okay, that's wrong. What we do is this, C6H6. That's my final answer. So another way of writing this is C1H1. So you multiply these subscripts by this number here, okay? So once you have the empirical formula, that's the hard part, finding the empirical formula. Once you have that, and I don't know if I said, formula mass and molar mass can be used interchangeably. It's the mass of the molecular formula. Once you have these two pieces of information, it's fairly smooth sailing to go to the molecular formula. So let's look at one more example together. So in some situation, I have a molar mass of 34 grams per mole. I know that the compound is 0.44 grams of hydrogen and 6.92 grams of oxygen. So a couple of options here. I can convert these to percentages, percent composition, then assume 100 grams, okay, then convert from grams to moles and do the whole empirical formula process. I can also go ahead and just drop both of these numbers down here. 0.44 grams of hydrogen, 6.92 grams of oxygen. If you go through and convert these to percentages and assume 100 grams, you'll get the same answer in the long run. So we'll go ahead and take a few shortcuts here. So we can convert this from grams to moles to 1.01 grams of hydrogen, 1 mole of hydrogen, grams of oxygen, moles of oxygen, 16.00. Okay, grams of hydrogen, grams of hydrogen, grams of oxygen, grams of oxygen. So 0.44 divided by 1.01 is equal to 0.4356 moles of hydrogen. And I have 6.92 divided by 16. And I get 0.4325 moles of hydrogen. Okay, so here we can see that it's probably pretty logical to go ahead and round those two to the same number. Okay, so if you went through the steps and divided them both by the smallest number of moles, obviously here you would get 1. So if I divided this by 0.4325, and if I did the top, 0.4325, let's go and type it in so we get 0.4356 divided by 0.4325, we get 1.007. So I can round that to 1 as well. So now I know that my empirical formula here is 1 hydrogen and 1 oxygen. Okay, so that is my empirical formula. But I asked for the molecular formula, so I need to go ahead and work my steps to find the molecular formula. So I add up the mass of the empirical formula. So 16 plus 1.01, and I get 17.01. So I take the molar mass, 34.00, divided by 17.01. Type that in the calculator, you get a number that you can very easily and logically round off to the number 2. Okay? So I multiply the empirical formula by 2, I get H2O2. Okay, so this is my molecular formula. Okay? So again, if I couldn't easily turn that into a whole number and couldn't easily turn these into a whole number, we know we've gone wrong somewhere. So this is actually known as hydrogen peroxide. So again, if you've gone through the steps and said, and you added up the mass of hydrogen and oxygen, you got the total mass of the compound here divided by, or excuse me, by the mass of the sample. Let me back up. You added these together, got the total mass of the sample, divided the mass of hydrogen by the mass of the sample, got percent composition, multiplied by 100, converted from grams to moles and going on. You would have gotten the exact same final answer here. So if you wanted to do that, kind of as a proof on your own notes, you can. So now we have the tools to go from a percent composition all the way to a molecular formula, the actual formula of a compound. So we'll do a little activity either in class or you'll do it on your own at home depending on how the format you're taking this class in. And it'll show you some very real world examples and how you can actually find the molecular formula for some very common compounds from some data that we would be able to easily attain from some chemical instruments.